All right, ladies and gentlemen, you may have noticed that I'm not there and that I'm not feeling sick, so forgive me now if I sniffle while I do this. I will do my best, though. All right, so one of the three most missed questions on the quiz was number two. We have Marie rode her bike 325 kilometers in 25 hours last month. Tamara rode her bike 255 kilometers in 15 hours last month. Are these speeds proportional? And explain. So, one thing that we could do just to see whether or not they're proportional, if you remember, is we could set up two ratios, 325 in those 25 hours, and see if that's equal to 255 kilometers in 15 hours. And whichever way you work this out, even if you just cross multiply, you will find out that no, they're not proportional. So I'm going to skip that part and just go straight into solving for your best answer. If I look at most of these answers, they're talking about rates of speed, we're talking about one of them going faster than the other, we're talking about them going about the same. Then we just talk about how to find both speed rates, which is actually this part is true. The question is the yes true? So let's see. Marie went 325 kilometers in 25 hours, and Tamara went 255 in 15 hours. So let's set those up as ratios. There's Marie, 325 kilometers in 25 hours, and there's Tamara, 255 kilometers in 15 hours. Oh, it's really hard to compare these, isn't it? I can't tell who's going faster. I can't tell if they're going the same speed. So what am I going to do? I'm going to find the unit rates. I'm going to see how fast they were each going. So I want to get Marie's speed so that it's over 1 hour, right? That's a unit rate. So to do that, I'm going to divide the numerator and the denominator both by 25 because I need to get from 25 to 1. And when I divide 325 by 25, I will find that she's going 13 kilometers per 1 hour. Okay, and I'm going to do something similar here for Tamara. I want to get her unit rate, so a denominator of 1. 15 divided by 15 is going to get me that denominator, so I've got to do that with my numerator as well. Divide by 15, and I end up with a numerator of 17 kilometers. Now I can compare. Marie is going 13 kilometers per hour, but Tamara is going 17 kilometers per hour. So they're not proportional, right? Because I simplified them both, and they simplified to different values. So I'm going to then say, clearly it's one of these two no answers. Is Marie's distance in time greater than Tamara's distance in time? Well, who cares? If one is greater than the other, that doesn't mean that they're not proportional. So the answer is A. They are not proportional. We already said they're not proportional. But Marie's rate is 13 kilometers per hour. There we go. Tamara's is 17 kilometers per hour. There we go. B, yes, while this was true, to find the speed rates, that's what we ended up doing. It's not yes, they're not proportional, so we know it's not B. C, well, it was no, but we already talked about that one. And D, let me back up just a little bit. There we go. D, again, that's wrong. And then to say that they're almost the same, no. Tamara's a lot faster than Marie, so it's not that. Okay, one of the other most missed questions was number 4. Okay, the graph shows the distance a boat is traveling over time. Does the boat travel at a constant speed? If so, how fast is the boat traveling? Well, first let's take a look at our graph. Oh, it's got a straight line. It's going through the origin. That means it's proportional, doesn't it? Now, what does whether or not it's proportional have to do with a constant speed? Well, what this means is that for each hour, it's going up the same amount. That sounds constant, doesn't it? For each hour, she's going the same distance. And also, let's think about if the relationship is proportional, what does it have? It has a constant of proportionality. Look at that word, constant. It's because it's constant. It stays the same, right? It's that many miles per hour each and every time. All right, so we know that it can't be C, which a lot of people said, which is why I talked about that. It's constant. Now the question is, how constant is it? Or rather, not how constant. That's silly. The question is, what is the speed that the boat travels at a constant rate? Okay, so let's see. We could try to take a look at this point. I think that the line is crossing at what number is that right there? So if I didn't want to risk it, I could say for sure, oh, I see that point definitely for sure there at 2 comma 10. But is that telling me that it's going 10 miles per hour? Let's see, if I put my y over my x, how many miles is it going per hour? I reduce that to get my unit rate. Oh, look at that, 5 miles per hour. There's my unit rate. My unit rate, that's the point that I would find right there. It's going 5 miles per hour. Okay, and the last one I want to go over. Let's see, we've got 3 sets of ordered pairs that appear on a graph showing the total distance bicycled after a certain number of hours. So they went 2 hours and 30 miles, 2.5 hours, 37.5, 3 hours, 45 miles. What ordered pair on that graph shows the unit rate? Remember, the graph is not just these points. The graph might be a line. And in this case, because we're bicycling, we can bicycle parts of hours, so it's definitely going to be a line. And beyond that, we're looking for the unit rate. Unit rate is key. What does the unit rate represent? So if you went to this answer, which was the most common wrong answer, that's not a unit rate, right? Yes, it represents a distance of miles, but this has nothing to do with the unit rate. Unit rate. But this is an important point, isn't it? So if we set that to a rate, 30 miles per 2 hours, and then, remember, we got to put our y over our x, and then we reduce that to get our unit rate. How far is it going in 1 hour? 15 miles per hour. Now we can convert that to a point. 1 comma 15. That's going to be on our graph. And there's our answer, C. The unit rate is at 1 comma 15. That's the ordered pair. And it represents bicycling at 15 miles per hour. That's how fast it's going. It's not going 30 miles per hour. It's going 15 miles per hour. That is a unit rate. Okay. Yeah. While I'm on this one, actually, let's talk about this one. This is an important point to notice. That 0, 0, the origin. Yeah, it's the origin, but what does that mean? This is the important thing that the origin might mean. It represents the initial distance before cycling. So this, when you've got that in your study guide, what does 0, 0, the origin, represent? It's asking, what does it mean? Does it mean how far they went before bicycling? Does it mean how many miles they went in 0 hours, which it would also mean? This is what that's asking. Okay. Alrighty then. Continue being wonderful. And I will see you Thursday, bright-eyed, bushy-tailed, and ready to take your unit tests, ready to show off your knowledge. And yes, we will go over the study guide, so do your best on it. And we'll go over those and have whatever discussions you guys need to have. So, all right, I'm babbling nonsense. Clearly, it's, yeah, whatever. Goodbye, Miss Decker. I'll see you guys Thursday or Tuesday. Wednesday. Bye.